Assalamualaikum warahmatullahi wabarakatuh. Good morning, the honorable audience. My name is Riska Leila Amaria. I am from Riska University, majoring in food science and biotechnology. And now I want to tell you about our research, which title is Functional Characterizations of the Protein Extract and its application in gluten-free food products. So I was starting for the introductions, which are starting from the soybean, are a widely utilized source of plant-based protein in the food industry and are commonly processed into the different products such as tofu. The conversion of soybean into the tofu involves the heating and the addition of acid coagulants, which can induce the protein denaturations and increase the surface hydrophobicity. These triggers might change in the functional characteristics of the proteins in tofu. In this research, the soy and tofu protein extracts were applied to the food products prepared using the different methods, which are steam cake using the steaming, and cookies cake using the pan baking, and the white bread using the oven baking. So the different processing method indicate the suitability of protein with specific characteristics. So the study is aimed to evaluate the effects of the soybean and tofu processing on protein characteristics and to assess the suitability of tofu protein extracts in improving the physical properties of gluten-free products produced by different processing methods. So we continue about the method. The first step is for the characterizations. We started from the raw material. We have soybean and also the tofu here, and then we got the powder form from the freeze drying process, and then we continue the powder form of the raw material into the extractions of protein extraction using the alkaline method, and then we cut the protein extract in the wet basis, and then we freeze drying the protein extracts so that we can get the protein concentrate into the powder forms. This protein concentrate is used to the characterizations, including the proximate properties, forming properties, emulsifying properties, solubility, water holding capacity, hydrophobicity, and also the molecular characterizations using the SDSPH and also the LCMS. And then we continue with the applications using the three products, which are steam cake, cookies cake, and also the white bread. We add 2% of protein extract, and then we also use the control product, which the positive control is for the gluten products, and the negative control is the gluten-free food products without the protein extract additional. And then we characterize the products in analyze the specific volume, baking loss, porosity, texture, and also the color. And then we got the result and discussion. The first page is for the functional properties of protein extracts. In this table, we can see that the tofu protein has the increase or the high value in the emulsifying properties, the hydrophobicity, and also the solubility in the pH 8 and also the pH 6. So the first thing I want to say is about the emulsifying capacity. So it may cause because the denatured proteins are the more flexible and contain hydrophobic or the hyperactive residues, so that it can make it the tofu protein easier to position the hydrophobic side toward the oil and the hydrophobic side toward the water, so that the emulsifying value of the tofu protein is higher than the soy protein. And the second one is for the hydrophobicity. It also causes the deteriorations can open the tertiary folds, so it can expose the normally hidden hydrocarbon residues like leucine, phenyl, valine, tryptophan, and also it can expose the hydrophobic bonds into the surface of the protein structure. And the last one is for the solubility in the pH 8, which are the steam cake dough, and the 6 pH is for the cookies cake. So we can see in the pH 8, it has so high the value. It partially denature of the proteins, although the denaturation typically reduce the solubility. Tofu extracts tend to have the more dispersed proteins and open internal hydrophobic bonds, exposing the more changes residues. These things can increase the interactions with water. And furthermore, the coagulation process in tofu productions can break down the certain protein complexes into the more soluble forms. And then we got the result and discussion for the SDS page and also the LCMS. The first thing is about the SDS page. We can see in the slide is the soy protein for the K code. It have shown a more complex SDS page profile with distinct beta-glucinin and also the glycinin bands indicating the intracts of protein diversity. And then for the tofu protein, which the T code had a river, then and thinner bands indicating the protein denaturations and aggregation during the tofu making process. These changes are relevant into the functional outcomes that were observed, which are emulsifying, hydrophobicity, and solubility, as the open structure of the tofu protein improved these properties. So in the next one is for the LCMS. We can see that the tofu protein extract has the increasing in the L16 and also L-methionine. So in this data, we can see that the tofu have more hydrophobic amino acid, and so that it has the higher emulsifications and then more soluble in the certain pH values. But in the other side, the soybeans have the more soluble in general and richer in essential polar amino acids. So we got in the second side is for the application. The first thing is for the steam cake. You can see in these pictures the specific volume of the steam cake with the protein additional extract is lowest than the control products and also the soy protein. And we can also see that the pores of the steam cake, we use the tofu protein extract has the coalescence, so that we can say that it can use in this steam cake. So the next one is the cookies cake. We can see that there is no significantly difference between the soy protein and tofu protein. The pores is like a similar, but the physically it can say that it's good. So we coming next to the last one is for the white bread. We can see in this area, in this picture, the white bread, it has a good in the volume in the specific volume, especially into the tofu protein extract. It have a 2.555, and the pores is also in the good conditions than the soy. So we got the conclusions of the study. The tofu protein extract exhibited different functional characteristics than soy protein, with improvement in emulsifying properties, hydrophobicity, and solubility at specific pH. Its application to gluten-free products yields varying their results. In steam cake, it decreased the specific volume and the porosity. In cookies cake, it increased the baking loss and hardness, while in the white bread, it provides high specific volume, good price, and relatively soft texture with low hardness, moderate elasticity, and uniform pores. Although baking loss in this white bread is still high, the overall quality is better than conventional products. So, tofu protein extract has a great potential for application in oven-baked gluten-free white bread products. Thank you. That's all.